Observe this question. In the data, alpha plus beta is equal to gamma is given. Then cos square alpha plus cos square beta plus cos square gamma minus 2 cos alpha cos beta cos gamma is equal to how much? My dear friends, there has been the shortest way to answer this. What is that way? Every option is independent of alpha, beta, gamma. No alpha, no beta, no gamma is appearing in the options. At such a case, there has been a beautiful technique for us, of course. You substitute whatever angle you like to have in the place of alpha, beta, gamma, according to your will and wish. Well, I would like to take alpha is equal to 60 degrees and beta is equal to 30 degrees. What happens for gamma? 90. Isn't it? That is the first method, method 1. Let alpha is equal to 60 degrees, beta is equal to 30 degrees, implies gamma is equal to 90 degrees. Let me call it some k, say. What is the value of k? Cos square alpha, cos square 60 plus cos square 30, cos square 90, cos square 90 is 0, and here it is cos 90, cos gamma is cos 90 is 0, 0 into anything is 0, cos square 60 is 1 by 4, why? Because what is cos 60? Half, cos square 60, 1 by 4, cos 30, root 3 by 2. Cos 30 degrees is root 3 by 2. Cos square 30 is 3 by 4. 1 by 4 plus 3 by 4 is 1. Is it available? Absolutely. First option is the correct option. Done. No strain, no pain. Very simple. This is one way. If you can get this idea, well and good. Otherwise, is there any other theoretical procedure? Of course there is. We shall now be looking at that. We shall look at that. This is method 1. By substitution, automatically you are getting the answer to be 1. Next, there has been another method also, that is what we call it method 2. What is it? Cos square alpha plus cos square beta plus cos square gamma. You just consider this only. 1 minus sin square alpha plus cos square beta plus cos square gamma. What is cos square beta minus sin square alpha? It is just nothing but cos beta plus alpha into cos beta minus alpha. What is cos square gamma? Cos gamma into cos alpha plus beta. Can I write like that? What is alpha plus beta? Gamma. Cos gamma into cos gamma? Cos square gamma. Well, my dear, what is cos beta plus alpha? Cos gamma. This is cos gamma, this is cos gamma. Get it out. 1 plus cos gamma into 1 plus cos gamma into, what is that? Cos beta minus alpha plus cos beta plus alpha. Again, use the identities. Cos of A plus B plus cos of A minus B. What is that? 2 cos A cos B, isn't it? So this is 1 plus cos gamma into 2 cos alpha cos beta. This entirely, what is this? 2 cos alpha cos beta cos gamma. If you bring this to the left hand side, what do you have? K is equal to 1. In the left hand side, what are you having? Cos square alpha plus cos square beta plus cos square gamma. Minus 2 cos alpha cos beta cos gamma, which is just nothing but that. That is K required. So the answer is 1. So both theoretically and by substitution method also we are able to have the answer. This is the question. It's a nice question. And this question teaches us a lesson. as and when the options are independent of the variables alpha, beta, gamma, a, b, z, x, y, z like that which are involved in the question, then straight away you can use the substitution methodology or substitution technique. Whatever value you like, you have it. You get it substituted and get the answer. This is the question. No doubt it's a beautiful question. Look at the question. It looks so lengthy. There has been a little bit confusion. Of course, if you can follow the question carefully, slowly, peacefully, it is one of the simplest questions. As you can see, look at it. Sin cube x into sin 3x is equal to sigma r is equal to 0 to n cr cos rx. That is c0 cos 0, c1 cos x plus c2 cos 2x plus c3 cos 3x plus c4 cos 4x and so on. He asks you, of course c0, c1, c2, cn are all constants. Cn is not 0. Then what is n and what is cn? Up to how many places you are supposed to expand it? That is the question. Let me first take LH. This is the question. Ultimately we are supposed to solve it. Okay, LHS is equal to, in the place of sin cube x, I like to write 3 sin x minus sin 3x by 4. And in the place of sin x, I write sin 3x only. So that this is 3 by 4 into sin 3x sin x minus 1 by 4 into sin square 3x. Here we need two identities, two formulae. What are they? One thing is 2 sin A sin B is equal to cos of A minus B minus cos of A plus B, and the other is 2 sin square A is equal to 1 minus cos 2A. I am writing this 3 by 8 into 2 sin 3x sin x, 1 by 8 into 2 sin square 3x, 3 by 8 into, come on friend, 2 sin A cos B. What is the formula? Cos of A minus B minus cos of A plus B. Cos of A minus B is cos 2x. Cos of A plus B is cos 4x. 1 by 8 into 2 sin square A. What is the formula? 1 minus cos 2A. So it is 1 minus cos 6x. 1 minus cos 6x. What is the least multiple angle involved in cosine function? 2x. So it is 3 by 8 cos 2x minus 3 by 8 cos 4x minus 1 by 8 plus 1 by 8 cos 6x. Isn't it? Well, these are used, of course. I like to remove them. This is equal to RHS. You compare C naught cos 0x is cos 0 is 1. So what is C naught here? Minus 1 by 8. C1 cos x must be present. Is there any cos x? No cos x. So C1 is equal to 0. What about C2? C2 means coefficient of cos 2x, 3 by 8. C3, coefficient of cos 3x, not available. C4, coefficient of cos 4x, it is available. What is that? Minus 3 by 8. C5, coefficient of cos 5x, it's not available. C5 is 0. C6, coefficient of cos 6x, what is that? 1 by 8. C7, cos 7x is not available. Cos 8x is not available. Cos something, etc. After 6x, they are not available. So, what is the largest possible place of C0, C1, C2, etc. Cn? Cn, and Cn is 1 by 8 and n is 6. Therefore, n is 6 and Cn is 1 by 8. Up to 6th place only you are supposed to make a move. Why is it necessary to calculate all these things? Actually speaking, not necessary. He has asked just about Cn. If at all there is another question, if he asks you find the sum of all those constants C0 plus C1 plus C2 etc. If he asks like that, you add all of them. You must be able to find. This is the question. Actual question is very simple. Actual question is very simple. The next question before us is eliminant of x from the set of equations a sin x square is equal to b cos x square is equal to 2c tan x square by 1 minus tan square x square is. In our earlier classes, we could have dealt with those problems in which some theta is to be eliminated and the resultant relation is supposed to be obtained. They are very simple. It does not mean that it is very difficult. It looks special, something special it looks. There is x square but not x here. Sin of x square, cos of x square, tan of x square. And we are supposed to eliminate x. If at all there are sine function and cos function in two equations, rather two pieces of information, we are supposed to use sin square theta plus cos square theta is equal to 1 for the process of elimination. If the equations involve, if in the equations tan theta and secant theta are involved, we use secant square theta minus tan square theta is equal to 1. If in the equation cosecant theta and cot theta are involved, we make use of the identity cosecant square theta minus cot square theta is equal to 1 for the elimination process. See, the special item here, observe, is sine function, cosine function and tangent function. 3 functions are given. And the luckiest thing is they are equal. Okay, let us try to eliminate x. Actually, it is x square. We are supposed to eliminate x square. Look here. A sin x square is equal to b cos x square. Therefore, tan x square is equal to b by a. From this usual and rough estimation, let this be b, let this be a. So automatically this is root of a square plus b square. I like to call this some x square. Tan x square is b by a. From this, cos x square is, what is cos x square? A by root of a square plus b square. Am I correct? It is a by root of a square plus x square. Now, you can have either cos x square or sin x square as you like. Now you multiply both sides by b. What do you have? B cos x square is equal to ab by root of a square plus b square. But from data, this b cos x square is equal to 2c tan x square by 1 minus tan square x square, isn't it? Therefore, ab by root of a square plus b square is equal to 2c into what is tan x square? B by a. What is tan square x square? B square by a square. Multiply both numerator and denominator by a square. What happens? 2abc by a square minus b square. This is aby. You can cancel ab of course on the numerator directly. You have a square minus b square is equal to 2c into root of a square plus b square. After ignoring ab, you have a square minus b square is equal to 2c into root of a square plus b square. And square it on both the sides, so you will be having a square minus b square whole square is equal to 4c square into a square plus b square. That's all. That's it. That is the way in which we can eliminate x square. Of course, x, that is the element of x from the given equations. It's a nice question. Let us start to solve it. A cos 2 theta plus b sin 2 theta is equal to 0. So a plus b tan 2 theta is equal to 0. So tan 2 theta is equal to minus a by b. So 2 tan theta by 1 minus tan square theta is equal to minus a by b. So 2b tan theta is equal to minus a plus a tan square theta. 2b tan theta is equal to minus a plus a tan square theta. Therefore, a tan square theta minus 2b tan theta plus a is equal to 0. Now, it is given that a alpha and beta are the roots of that equation. Automatically, we can take tan alpha and tan beta are the roots of this equation. So that we have tan alpha plus tan beta is equal to, that is the sum of the roots of this equation is minus b by a is nothing but 2b by a. 2b by a, and product of the roots is tan alpha into tan beta is equal to, what is that? It is a tan square theta minus 2b tan theta. It is minus, not plus. So minus a by a is 1. I'm sorry, minus 1. So tan alpha plus tan beta is 2b by a, and tan alpha tan beta is minus 1. But what is required here? Tan of alpha plus beta. What is tan alpha plus beta? Tan alpha plus tan beta by 1 minus tan alpha tan beta. What is tan alpha plus tan beta? 2b by a. What is tan alpha tan beta? Minus 1. 1 minus of minus 1 is 2. 2 and 2 go away, leaving you b by a. What is tan alpha plus beta? It is b by a. It is b by a. Another question before us is, three real numbers cos x minus y, cos x and cos of x plus y are in HP. He is giving us. Then what is the value of cos x into secant y by 2? That is the question. A nice question, which is something different from the usual and general style of questions. Look here. Let us recall the concept of harmonic progression. If A, B, C are in HP, what do you call about B? It's nothing but the harmonic mean of A and C, and it is given by 2AC by A plus C, isn't it? Therefore, by making use of that concept, cos x is equal to 2AC by A plus C, right? Isn't it? Cos x plus y into cos x minus y. What is that? Cos x plus y into cos x minus y. Cos square x minus sin square y by cos x plus y plus cos x minus y. What is it? 2 cos x cos y. Cos x is equal to. Here 2 will be cancelled. No question of presence of 2. Now cross multiply. Cos square x into cos y is equal to cos square x minus sin square y. implies cos square x cos y minus cos square x is equal to minus sin square y. Minus sin square y. Or you obtain cos square x as a common factor. Cos square x into 1 minus cos y is equal to sin square y. Of course, I have multiplied with the minus sign on both sides. Therefore, cos square x into 2 sin square y by 2, 1 minus cos y is 2 sin square y by 2. Again, what is sin y? 2 sin y by 2 cos y by 2. You square it. 4 sin square y by 2 cos square y by 2. 1, 2 will be cancelled. Sin square y by 2 will be cancelled. You bring cos square y by 2 here, so that cos square x into secant square y by 2 is equal to 2. Is equal to 2. Because only 1, 2 will be cancelled, another 2 will be remained here. You see, sin y is nothing but 2 sin y by 2 cos y by 2. If you square it, you will be getting 4 sin square y by 2 cos square y by 2. After ignoring sin square y by 2 on both the sides, you will have cos square x into secant square y by 2 is equal to 2. Therefore, cos x into secant y by 2, which is required, is of course plus or minus root. Plus or minus root 2. That's it. The next question is the value of sin 20 degrees into 4 plus secant 20 degrees is, yes, given some options, some root 3, 1 by 2, 3 by 2, like that. Here there are no variables. You cannot use substitution method. You must do it. You must solve it. Let us try. What is it? Sin 20 degrees into 4 plus secant 20. He has asked is equal to sin 20 degrees into 4 plus, what is secant 20? 1 by cos 20. Okay, this is sin 20 degrees by cos 20 degrees into 4 cos 20 degrees plus 1. I have just taken the LCM. Now you send sin 20 inside the bracket. 1 by cos 20 degrees into 4 sin 20 degrees cos 20 degrees plus sin 20 degrees. The next question is the value of sin 20 degrees into 4 plus secant 20 degrees is, yes, given some options, some root 3, 1 by 2, 3 by 2, like that. If there are no variables, you cannot use substitution method. You must do it. You must solve it. Let us try. What is it? Sin 20 degrees into 4 plus secant 20. He has asked is equal to sin 20 degrees into 4 plus, what is secant 20? 1 by cos 20. Okay, this is sin 20 degrees by cos 20 degrees into 4 cos 20 degrees plus 1. I have just taken the LCM. Now you send sin 20 inside the bracket. 1 by cos 20 degrees into 4 sin 20 degrees cos 20 degrees plus sin 20 degrees. Well, my dear, 2 sin theta cos theta is sin 2 theta, but here is 4 sin theta cos theta. So it is 2 sin 2 theta. That is 1 by cos 20 degrees into 2 sin 40 degrees plus sin 20 degrees. Right? Okay. This is equal to 1 by cos 20 degrees into sine 40 degrees plus sine 40 degrees plus sine 20 degrees. I have distributed this 2 sine 40 as 1 sine 40 plus sine 40. Now you can use sine c plus sine d transformation formula. What is sine c plus sine d? 2 sine c plus d by 2 cos c minus d by 2, isn't it? So it is 1 by cos 20 degrees into sine 40 degrees plus 2 sine c plus d by 2. 40 plus 20 by 2. 40 plus 20, 60. 60 by 2 is 30 into cos c minus d by 2. 40 minus 20 by 2, that is 10. 10 degrees. This is equal to 1 by cos 20 into, after getting that 2 and sin 30, you can write sin 40 as cos 50 plus cos 10. Cos 10. Now you make use of cos c plus cos d. What is cos c plus cos d? 1 by cos 20 degrees into, come on, what is cos c plus cos d? 2 cos c plus d by 2. 50 plus 10 by 2. 60 by 2 means 30 into cos c minus d by 2. 50 minus 10 is 40. 40 by 2 is 20. 20 cos 20 and cos 20 can be cancelled. What is cos 30 degrees? Root 3 by 2. 2 into root 3 by 2 is root 3. So what is the simple answer for this question? It is root 3. It's a beautiful question.
Observe the next question. X is an angle which lies either in the first quadrant or in the second quadrant, that is 0 less than x less than pi. It has also been given that cos x plus sin x is equal to half, and we are supposed to have tan x. Look here, cos x plus sin x is equal to half. 1 by root 2 cos x plus 1 by root 2 sin x is equal to 1 by 2 root 2. 1 by 2 root 2. So cos of x minus pi by 4 is equal to 1 by 2 root 2. Well, my dear, x is less than pi, so it should lie either in the first quadrant or in the second quadrant. But cos of x minus pi by 4 is positive, so x minus pi by 4 is acute, no doubt. It is acute. So by making use of this with our rough estimate 2 root 2, this is 1. Automatically this is root 7, isn't it? This is of course theta, that is x minus pi by 4. From this, tan of x minus pi by 4 is, what is tan of x minus pi by 4? Is root 7. Root 7 by 1. Isn't it? Okay. Why I am able to have directly x minus pi by 4 is acute, so tan of x minus pi by 4 is also positive. Why should you say, or why are you confirmed to say that x minus pi by 4 is acute? Cos theta is positive. So it should lie either in the first quadrant or in the fourth quadrant. But in the beginning he says that either x either lies in the first quadrant or second quadrant. So this x minus pi by 4 should lie in the first quadrant. That is why it is positive. Tan of x minus pi by 4 is root 7. Well, what is tan of x minus pi by 4? What is tan of x minus pi by 4? Tan x minus tan 1, tan x minus tan pi by 4 by 1 plus tan x tan pi by 4 is equal to root 7. It is tan x minus 1 by tan x plus 1. Use componendo dividendo. What happens? This plus this is 2 tan x. This minus this is minus 2 is equal to root 7 plus 1 by root 7 minus 1. Are you sure of that? This plus this, 1 will be cancelled, 2 tan x. This minus this, tan x will be cancelled, minus 2 will be there. So that 2 and 2 will be cancelled. Tan x is therefore equal to minus of root 7 plus 1 by root 7 minus 1. Minus 1. Therefore, x lies in the second quadrant and x minus pi by 4 lies in the first quadrant. He has just asked us to have the value of tan x and we have got it. And if you want to get it rationalized, it can be done also. This is nothing but root 7 plus 1 whole square by 7 minus 1, 6. According to the necessity and then according to the available options, so you are supposed to use the steps of simplification from there on. Of course, for this question among the options, he has given the option 1 plus root 7 by 1 minus root 7. It is correct. That is why I have stopped there itself. The next question looks so lengthier and something is there. Yes, something mischievous it looks. Let us see. There are so many angles involved in this problem. Alpha 1, alpha 2, alpha 3, etc. alpha n. He has given that they are all acute. So they lie between 0 and pi by 2. So 0 less than or equal to alpha I less than or equal to pi by 2. Okay. Moreover, the additional information that has been given here is cot alpha 1 into cot alpha 2 into cot alpha 3 into etc. cot alpha n is equal to 1. We are supposed to make use of this information. From this, you are supposed to get the maximum value of cos alpha 1 into cos alpha 2 into etc. cos alpha 3 into etc. cos alpha n. It is definitely differs from the general style of problems. Yes. Let us approach it. This has been given. From this we have cos alpha 1 into cos alpha 2 into cos alpha 3 into cos alpha 4 into etc. cos alpha n is equal to sin alpha 1 into sin alpha 2 into etc. sin alpha n. Now multiply both the sides by cos alpha 1 into cos alpha 2 into etc. cos alpha n. What happens? LHS becomes cos alpha 1 into cos alpha 2 into cos alpha 3 into cos alpha n whole square is equal to 2 sin alpha 1 into cos alpha 1, 2 sin alpha 2 into cos alpha 2, 2 sin alpha n into cos alpha n by 2 power n. Am I correct? Already sine functions are there. We are multiplying with cosine functions. Automatically product of sine function and cosine function will be there. Let us gather them in a suitable bracket and apply 2. How many 2's you have supplied in the numerator? N 2's. Okay, let them be cancelled, of course, by taking 2 power n in the denominator. Good. This is equal to 1 by 2 power n into sine of 2 alpha 1, sine of 2 alpha 2, sine of 2 alpha 3, sine of 2 alpha n. But we know pretty well that sin 2 alpha 1 is less than 1, cos 2 alpha 1 2, sin 2 alpha 2 is less than 1, sin 2 alpha 3 is less than 1, etc. sin 2 alpha n is less than 1. Therefore, this is less than or equal to 1 by 2 power n into 1 into 1 into 1 into 1 into 1. Of course, it is just nothing but 1 by 2 power n. What do you observe? Cos alpha 1 into cos alpha 2 into etc. cos alpha n whole square is less than or equal to 1 by 2 power n, and from there on you can say that cos alpha 1 into cos alpha 2 into etc. cos alpha n is less than or equal to root of 1 by 2 power n, that is nothing but 1 by 2 power n by 2. So what is the maximum value of cos alpha 1 into cos alpha 2 into etc. cos alpha n is 1 by 2 power n by 2. What is the required answer? 1 by 2 power n by 2. My dear friends, you please observe the style of obtaining the answer. It is less than or equal to 1 by 2 power n by 2. Always, irrespective of the nature of alpha 1, alpha 2, etc., alpha n, below 90. No problem. So it is 1 by less than or equal to 1 by 2 power n by 2. Nice question. Special problem.